Supervised versus unsupervised. We touched on that in the first and the second lecture. Basically, supervised learning is the type of learning where you're trying to predict something specific. So maybe you're trying to predict the closing price of Dow Jones tomorrow. That's a very specific thing. And tomorrow you will know the exact answer, so you can see how well you have done. Or maybe you're trying to predict whether an email is ham or spam. That again is a very, very specific thing which has a very specific answer, yes or no. Supervised learning typically requires training examples with labels. So you have you need to have example emails that are labeled spam or not spam. And another property of supervised learning is usually you can measure directly how well your learning algorithm is doing. So if you're predicting spam, you can have a human come in and label the emails, and you can measure what is your accuracy, how many emails have you labeled correctly and incorrectly. And for predicting Dow Jones, your algorithm will spit out a number. Tomorrow you will learn the true number, and you can look at the difference between two numbers. In both cases, you can directly measure how accurate or inaccurate your learning algorithm is. Unsupervised learning, the goal here is you're not really looking for something specific. You're not trying to predict something specific. What you're trying to do is you're trying to learn a little bit about the data that you're dealing with. So maybe you're trying to uncover the structure of the data, or maybe you're looking for unusual patterns. In all cases, you're not exactly sure what it is that you're looking for. Right? Before your algorithm runs, you cannot say what you expect to see as the output. That's kind of a hallmark of unsupervised learning. You're trying to learn something about your data. Now, unsupervised algorithms, they typically don't require labeled data, so you just get instances and you run the algorithm on them and it produces something. And evaluation of unsupervised algorithms is also different in the sense that because you don't have labels, because you're not trying to predict something specific, you cannot say how accurate or inaccurate that part of the algorithm is. What you can do is either use indirect evaluation or qualitative evaluation. Qualitative, it means you look at the results and you ask yourself, well, does it help me learn something about my data? By looking at the output of the algorithm, do I see something with my human eyes that helps me understand what the data is all about? Indirect evaluation, we'll talk about that more a few lectures down the line, is when you use the output of an unsupervised algorithm to improve some other component in your system. So maybe you're using a clustering algorithm, and the output from clustering goes into your classifier or into your speech recognizer, and you're seeing how much better your classification accuracy became, or your word error rate, how much it's gone down. Question?
So you're talking about saying that it's looking for structure and unusual patterns, and it's not looking for something that's concrete, looking for a quantitative value, right?
Yes.
Are you saying that for all of unsupervised learning? Because I mean, you have general value functions and things like that that do very quantitative things, right? Making predictions over time. Let's say the Dow Jones.
Yes.
What the closing values are going to be. So, are you saying that wouldn't be considered unsupervised, or?
Okay, so I think what you're getting at is, could you use an unsupervised method for a supervised task?
Well,
yes, you could.
Okay.
Absolutely.
Oh. Okay. Yes. Okay. Never mind. Yes. Okay. I see where you're going.
Yes. So you could definitely use a method that doesn't require any training, and you could apply it to a task that is usually solved with supervised methods.
Okay.
It probably will not be very good at whatever it's doing if you don't actually give it. If you make it truly unsupervised, this means you don't let it see the historical data on Dow Jones.
Okay.
In which case, it probably won't be a very good predictor.
Yeah.
Yes. But could you? Yes, very much you could.
Okay.
You could certainly take an unsupervised method and use it for predicting something. Use it basically in a way that you would use a supervised method. Yes, you can. And that's actually where semi-supervised comes in. It's because when you deal with things in practice, you will get data sets where you have lots and lots of unlabeled instances and usually a small amount of labeled data. And what you want to do then is you kind of want to take the benefits of unsupervised algorithms, the ones that don't require training data to learn the structure of the data, and then take advantage of whatever supervision you have using a supervised method. So semi-supervised, that's what that is trying to do.